Hello, today I'll be going over the 2020 May CodeChef Lunchtime Problem Number 2 solution, which is Weird Walk. The problem statement is Alice and Bob are walking on an infinite straight street. Both initially are at the position x equal to 0, and they start walking in the direction of increasing x. After n seconds, they stop. Let's denote Alice's speed and Bob's speed during the ith of these seconds by ai and bi respectively. Sometimes Alice and Bob walk together, with the same speed side by side. Let's define the weird distance as the total distance they walk this way. Find this weird distance. We are given that the weird distance is when both Alice and Bob are standing at the same position and walk at the same speed or for the same distance. Therefore, we only need to find the positions where Alice and Bob are together at the same point in time and walk for the same distance, which will be the same rate. Then we can add this distance to our total weird distance counter. We can then read through the arrays and keep adding the distance they walk, one by one, to their current position. If we find the position where both Alice's counter is equal to Bob's counter, we have to check the next constraint, which is if they walk together and for how long. We can check this by checking the next distance they will walk. If both distances are equal, then we know they walk together at the same pace for that entire distance, and we can add that distance to our final counter. At the end, we can print out our final counter and move on to the next test case. Now let's go over a simulation with the solution. So you start with the Alice position and Bob position both equal to x, which is equal to 0, as stated in the problem statement. And right now, they have walked for a weird distance of 0. So we see that their positions are equal, as stated in our find operation. So because their positions are equal, we check the distances. Both are walking one distance. Therefore, from position 0 to position 1, they will both walk together for a distance of 1. So we can update their position. Now, since both of them have walked one distance, both of their positions are equal to 1, and the weird distance, we know that they have walked together, so their weird distance also becomes 1. Next, we check the next element. We see a 3 and a 2. However, 3 is unequal to 2, so therefore they're not walking at the same rate. And if we update Alice's position, we see Alice's position becomes 1 plus 3, which is equal to 4, and Bob's position becomes 1 plus 2, which is equal to 3. So now they're at different positions. Therefore, when we move on to the next set of numbers, which is the 3 and the 4, we can see that they cannot walk together if they're not at the same position. Therefore, we can just update their new positions without having to worry if they walk together. Their new position, Al's position becomes a 7, 4 plus 3. Bob's position becomes a 7, 3 plus 4. So now we are moving on to our last elements, which is the 4 and the 4. So now, in this case, we see that Al's position is equal to Bob's position, 7 is equal to 7, and the distance, Al's distance 4, is equal to Bob's distance 4. Therefore, we can add this to our weird distance counter and update both Al's position and Bob's position. Al's position becomes 7 plus 4, 11, Bob's position same, and weird distance becomes 1 plus 4, which is 5. Therefore, we have calculated our weird distance, and our weird distance answer becomes 5. Now let's go over how to code the solution. The input consists of t test cases, and for each test case, an integer n and 2 arrays of distances traveled from Alice and Bob of size n. After we take in the input, we can start our simulation by creating our counters for the current distance Alice traveled, which can be written as dist A, the current distance Bob traveled, dist B, and the total counter for the weird distance they walked together, which would be counter. We will check each time we iterate to a new position in the array if the current position of both Alice and Bob, which are dist A and dist B, if they are equal, and if so, we will check if the distance they are going to walk, which would be A of I and B of I, are equal, and if so, we are going to add the distance they walked to counter. Then we are going to add the distance they walked individually to the current position to update it and find the new position each of them are at. Then we are going to print out counter and return 0. Sorry, over here counter should plus equal A at position I or B at position I, because we're going to add the total distance they walked together. Submitting this, we do see that we get a correct answer.